Suppose you have a sample of gas that satisfies the equation P is 2000 divided by V, where P is its pressure in pascals and V is its volume in cubic meters. And we want to know how quickly the volume is changing when the pressure is 100 pascals and the pressure is decreasing by 5 pascals per second. So again, this is a related rates problem because we know about the rate of change of one quantity, in this case pressure, and we want to know about the rate of change of another one, in this case volume. So you can think of this in a couple of ways. Either we're going to use that dV dt, the rate of change of volume over time, is dV dP times dP dt. Or you could actually kind of flip things around and say, well, dP dt is equal to dP dV times dV dt. Right, either of these ways works. In the first case, you would find the derivative of volume with respect to pressure, and in the second case, the derivative of pressure with respect to volume. So you can kind of take it whichever way you want. We already have the pressure solved in terms of the volume, but in this case it's pretty simple to sort of put it the other way. Maybe though, let me just keep it the way that it is for right now. So since pressure is written as a function of volume, I'm going to use the second way this time. So let's start by writing down all the information into mathematical notation. So we have this equation right here. Maybe I'll just kind of circle that. That's a bit of math. The second sort of half of that sentence just tells us about the units of the pressure and volume. So here's the question: how quickly is the volume changing? So that's asking you to find dV dt when the pressure is 100 pascals. So when P is 100. And then finally, when the pressure is decreasing by 5 pascals per second. Again, look at the units here. Pascals per second. That's units of pressure per time. And that's how you know that it's about the rate of change of pressure over time. And be careful because the derivative here is negative 5 because the pressure is decreasing by 5 per second. Okay, so with this equation up here and these pieces of information here in red, that's everything we need to solve this problem. So, what is the derivative of P with respect to V? Well, in this case, the easiest way is to rewrite P as 2000 times V to the negative first power. So that means that dP dV is negative 2000 times V to the negative second, which we can rewrite as negative 2000 divided by V squared. So dP dt, well, that's the thing that I know, right? That's the negative 5. So negative 5 is equal to negative 2000 over V squared times dV dt, which is the thing I don't know. Well, now we seem a little bit stuck. In order to solve for dV dt, I need to know what the volume is. And I wasn't told what the volume is. I was only given a pressure. So how do we figure that out? Well, of course, if I know what the pressure is, I can use this equation to solve for the volume. So we have that 100 is equal to 2000 divided by V. And if I multiply both sides by V and divide both sides by 100, that's equivalent to saying that V is 2000 divided by 100. So in this case, 20. So now I can just plug that in over here. So negative 5 is negative 2000 divided by 20 squared times dV dt. Well, 20 squared is 400. And then negative 2000 over 400 is in fact itself negative 5. So we have that negative 5 is equal to negative 5 dV dt, and so the conclusion is that dV dt must be equal to 1. And that's, in this case, 1 cubic meter per second.